Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is maximum number of fish in a crate. Let's go to LeetCode and give this problem a read. You are given a 0 index 2D matrix called grid of size m into n, where RNC, that cell, represents a land cell if that value is 0, or a water cell containing that particular cell, that number of fish if this value is greater than 0. Okay, so a fisher can start at any water cell and can do the following operations any number of times. So catch all the fish at that particular cell or move to any adjacent water cell. Return the maximum number of fish the fisher can catch if he chooses his starting cell optimally. So we have to choose just one starting optimally so that we can explore, we can catch the maximum number of fishes. What we can do while catching the fishes, you can move to an adjacent cell vertically or horizontally, not diagonally. Okay, so an adjacent cell of this is basically, this is what I just said, vertically, horizontally. That's how you can move. This problem is exactly like maximum area of island. We just solved it. This is our code. We have written it right here. That's the exact code we will be writing. This is the exact code we will be writing, but I'll be copying and pasting it. But like, just problem is just like the wording is a little different. If you try to find these patterns, there will be multiple problems just like that. Okay, so let's switch our view. This is we can say this is basically the grid that has water and lands. Where is my water? The water is right here. This is water. All these zeros are, oh sorry, not water. All these zeros are land. So this is where you cannot fish. Where can you fish? You can basically choose any grid that has the value greater than 0, and that represents the number of fish. So if I am going across this grid, I see this 2, that means there are 2 fish. If I choose that, I can explore one more pond right next to it that has 1. So in total, but like there is no other fishes around this location. Okay, so I can only collect 3 fishes from here. So this is one location I can fish. If I'm the fisherman, I can fish right here and I get 3 fishes. What else I can do is, how about I choose this location? If I choose this location, this 4, so this 4, there are basically one more pond right next to it which has 1 more fish. So this together gives me 5 fishes. How about if I choose this 3? Then there are 5 fishes here. Then there are, so just like the maximum area island, I'm trying to find these groups of fishes right next to each other, and then I'm going to return the maximum number of fish this fisherman can collect or catch. So what do you see? What's the answer? 7. So can we find out optimally just 7 like itself without visiting all the cells and all these group of fishes? No, we cannot. What are we going to do? We're going to visit our grid. Whenever you see a value, that value is greater than, if this grid I and j, if we are visiting like that, if it is greater than 0, that means there are fishes. If there are fishes, what do? We collect these. We're gonna basically collect these fishes and sum them up together, and then return all these neighboring fishes number. So that's how we did it in the maximum area island. And the way we did it, we were adding 1, but in this case we'll be adding the value. So as I said, I'm gonna copy and paste that code of maximum area, because like there is no point writing it again. We're gonna have the same number of same set of things, but we will be changing of course all the variables, and we will be changing our answer. So maximum area island becomes max fish, and this row and column remain same. This, if this is greater than 0, no, it's not equal to 1, it's greater than 0, and this is all not in visit set, then max fish would be maximum of max fish and whatever my DFS brings me. Okay, I'm gonna zoom into this code. Whatever this brings me. Let's go to our DFS. DFS here is RNC. It's gonna have the same thing, checking the bounds, checking other bounds. It's not in visit, and this value is, or this value is equals to 0. That means it's equal to land. This time also we are going to avoid this, because if you are at a land, then you're going to return 0. Otherwise you add it to your visit set, and instead of 1, what do you add? Grid R and C. That's the number of fish that has. Okay, and I think hopefully we don't have to change anything else. That would be our code, guys. Let's zoom out and run this on our examples, and hopefully if we understood the pattern right, it should get accepted. Yeah, of course, come on, we just forgot to return max fish instead of max area, and voila, yes. Let's submit our answer. Awesome. And I'm so happy that these patterns are coming up, like these problems are right next to each other, so it's easy to, you know, find these patterns, and then we later there might be a similar problem, but we can imagine that like this falls into that category, so we can solve it using the same pattern. All right, same code. We don't have to memorize the code. We wrote this code for max area island from scratch, but here we can reuse that. So time complexity is same, you know, just like the previous problem. N into M, we are visiting all the cells, and then space complexity is going to be big of N cross M as well. And that's it, guys. So let's go to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then,